Let's look at finding some missing angles today, and what we are going to be looking at is this shape right here, and as you can see there are a number of unknown angles that we need to try to calculate. So there are really only two concepts that you really need to know when you are trying to solve missing angles inside of shapes, and those two concepts that we're going to be dealing with today are supplementary angles, which are any angles when added together equal 180 degrees. And if we take a look at our shape, we have a number of straight angles here. We have an angle that's going this way, an angle that's going this way, and a transversal that is cutting across those two angles. So all of those lines are equal to 180 degrees, and that's going to be important when we are trying to figure this out. Concept number two is that we need to know what the interior sum of shapes are going to be. So we know that if we added all of the angles inside of a triangle together, it is equal to 180 degrees. Not just some of the time, but all of the time equal to 180 degrees. And this shape also has a four-sided figure, and we know that if we had a triangle which is three sides and it's equal to 180 degrees, then the interior angle of a rectangle or a four-sided shape has to be double a triangle, because there would be two triangles in this shape. So 180 degrees plus 180 degrees would equal 360 degrees. And if we can remember that, then solving the missing angles for the shape shouldn't be overly difficult. So let's get started and take a look at how we do this. So the first thing that we would want to do is we want to work with some easier angles. Okay, and easier angles are like straight lines. So if we take a look at here, we've got 48 degrees. So if I travel this distance, that is equal to 48 degrees of this entire straight line, or 180 degrees. So if I was to travel the rest of this right here, if this is a straight line, which it is, and I've already traveled 48 degrees of that, then I simply have 180 less 48 degrees, and that's going to give me this missing angle right here. And it just so happens that this missing angle would have to be, without even measuring using a protractor, would have to be 132. So I'm going to put 132 degrees in there. Now why is that? Because 48 degrees plus 132 is equal to 180. I'm going to switch different colors here because the blue is not showing up so great. Now that I have this angle right here, I know something else about this angle. Anytime a transversal cuts through parallel lines, it creates an opposite angle. And it just so happens that if I was to bring this angle across here, across its vertex, I would also know that this angle is 48 degrees. Okay? Now that gives me two angles just from looking at this guy. Let's switch over to this side and take a look. We have a straight line here. If I'm traveling 120 degrees right there, so there's the vertex angle right here, boom, boom, boom. If I have 120 degrees, it must mean that this angle right here, because it is a straight line, would have to be 60. Because 120 plus 60 gives me 180 degrees. So now I have solved a couple of angles inside of this shape. Now let's get away from the 180 degrees for a second and get into the triangle. I have enough that I could solve what this missing angle is in the triangle right here simply by taking this angle and adding them together. So this is going to look at what that second concept was looking at the sum of interior angles. And if we take these two angles and we add them together, 52 and 48, well, we get 100 degrees. And every triangle has an interior angle, doesn't matter what kind of triangle, of 180 degrees. So if I have 100 degrees of 180, it means I'm missing 80 degrees. So without measuring using a protractor, I know for sure 48 and 52 is 100. My missing angle has to be 80 degrees right here. Because 48 plus 52 is 100 plus 80 is 180, and I know that 180 degrees are inside of a triangle. So I've solved this triangle. Let's get back down here to, let's say, our quadrilateral. Now, one of the tricky things about this is that when you're looking at these lines, sometimes what you can do is you can take these lines and you can extend them out. So I'm going to extend this line out, and I'm going to extend this line out, and then what I've done is I've created a transversal, another transversal that's coming through, a line that's going to intersect these two parallel lines. Even though that line wasn't there before, it still can be made available. Now that's going to help me solve what this angle is, because if you remember in a previous video, when we looked at transversal lines, we looked at how angles kind of had a relationship when they went through parallel lines. And we looked at if this is the case, if this is 120 right here, and this is 60, then traveling across here would have to make this 60. And it just so happens that this angle is going to be the exact same as that angle, which means that if this is 120 right here, then this bottom one has to be 120 degrees. And if this bottom 120 is here, that means that this inside here has to be 120, and this would be 60, and this would be 60. So I figured out that these angles are all the same as here if I would have extended that line out. Kind of a neat little trick when you're working with transversals. And now that actually helps me out a lot, because if you take a look here, what I have is I've essentially taken this line, extended it out, given me this, and now it only leaves me with one angle left to deal with inside of the shape. We know the interior angle of any quadrilateral or any four-sided shape is going to be 360 degrees. And why is that? Well, if I split this quadrilateral in half, I've got two triangles. And two triangles, we know, are 180 degrees and 180 degrees for a total of 360. So let me get rid of that for a second because I don't want that to confuse you. I've got to figure out what this missing angle is. If I take 120 and 132 and 60 and I add them all together, I end up with, what do I get? I get 312? About 312? I think that's what I'm looking at. I'm looking at about 312. And if I take 312 and I subtract it from 360, I get a missing angle. I get 48. And it's interesting because this 48 and just coming across here is going to be equal to this 48 because these angles are going to be the same as well. So now if I take all of these and add these together, what I have here is I have 132 and 120 and 60 and 48, and all of it together equals 360 degrees. So I know without even using a protractor that that has to be the correct measurements. So that leaves me with one more angle that I have to figure out, and it's this guy right here. But that angle is going to be a little bit difficult to figure out because it doesn't give me this one. But it just so happens that if these angles are the same, this angle and this angle are the same, then it means if I came across this vertex and got the same number, that means I can come across this vertex and get the same number as well, which leaves me with an angle of 48 degrees. Now, I simply just need to do what I did with the previous triangle. I need to look at, if I added all of these numbers together, what would I get? And if I take 80 and add it to 48, I get 128. And that would mean that my missing angle has to be 52 degrees. If I take 48, add it to 80 and 52, I end up with 180, and 180 is the interior angle of a triangle. So all we needed to do for this, to recap, was we needed to know what straight lines were and how to get to straight lines if we had angles that were given to us. So let's take a look at that again real quickly just before I end this video. So if we had 120 here, I could figure out that this was 60 because 120 plus 60 was 180. This was 48. Add or subtract it from 180 and I get 132. That gave me a couple of angles inside, and then I remembered that a transversal can cut through two lines, and if it cuts through two parallel lines, then those angles, these angles are going to be the same, which is going to give me this angle right here. It's going to come across the vertex. It's going to come across the transversal rather, not the vertex. It's going to come across the transversal, and it's going to give me its opposite corresponding angle, which would be 120. When I added all those together, it gave me every number I needed except for this one, which would have been 48. Opposite angles came across the vertex here. This angle was given to me. I just needed to add them together to equal 180, and the same thing down here. So this is finding missing angles using two pretty simple concepts that you just need to remember. One, remember that interior angles of shapes are always going to be the same. Triangles equal to 180. Quadrilaterals or four-sided shapes are going to be equal to 360. A five-sided shape is going to be added to 540. And every time you add a line, you're simply adding 180 degrees to it. The second thing was just remembering to add up to 180, and you can figure out the interior angles of all of these shapes. If you want to rewatch this video, by all means, go ahead. If you have a question or you're confused by anything that we talked about, please drop a line. And thank you for watching.